The convoy was 3 hours behind schedule. British trucks strained under winter mud, their engines screaming in low gear, their drivers white-knuckled on steering wheels that fought back. Above them, reconnaissance planes circled. The Luftwaffe knew exactly where they were, and at 15 miles per hour, there was nowhere to hide. Sergeant James "Jimmy" Fletcher, a truck driver from Manchester who had spent 6 years hauling coal before the war, sat in his cab and understood something his commanders didn't. In 12 hours, those reconnaissance planes would return with bombers. The convoy would still be on this exposed road, and hundreds of men would die because British military trucks couldn't get out of second gear. He reached into his toolbox, pulled out a wrench, and prepared to commit what the Army would call sabotage and what physics would call genius. This is the story of a gear ratio modification so simple that trained engineers had overlooked it for 3 years. But it's really about the gap between institutional knowledge and practical wisdom, between how wars are supposed to be won and how they actually are, and what it reveals about innovation under pressure, the value of experience over credentials, and the moment when one man's stupid idea becomes doctrine because it saves lives when nothing else can. December 1942, North Africa. The Western Desert Force was learning a brutal lesson about the relationship between speed and survival. British supply convoys, the lifeblood of Montgomery's Eighth Army, were being systematically destroyed from the air. Not because the Luftwaffe was overwhelming, not because British fighters couldn't protect them, but because of something far more mundane and far more lethal. The trucks were too slow. This wasn't a minor tactical problem. This was physics imposing its will on military logistics. A Junkers 88 bomber flying at 280 miles per hour had all the time in the world to line up on a target moving at 15 miles per hour. British drivers could see the bombers coming, could hear the whistle of falling bombs, could do absolutely nothing except grip their steering wheels and hope. The trucks had governors, speed limiters installed by military regulation to prevent inexperienced drivers from damaging expensive equipment. Maximum speed on level ground, 25 miles per hour. Maximum speed under load in desert conditions, 15. The logic seemed sound. Preserve the vehicles, prevent accidents, maintain mechanical readiness. But that logic was written by people who had never driven through a bombing run with nowhere to hide. Jimmy Fletcher had driven trucks since he was 16, not military trucks, not in convoys, not under fire. He'd hauled coal through Manchester in vehicles held together by improvisation and prayer, working for companies that couldn't afford new equipment and didn't tolerate downtime. He'd learned something the Army hadn't taught him. Every mechanical system is a negotiation between what it's designed to do and what it needs to do to keep you alive. The Bedford QLs the British Army used were good trucks, reliable, maintainable, capable. But they were geared for durability, not speed. Low gear ratios meant high torque, which meant they could haul heavy loads through difficult terrain without breaking down. It also meant that even with the governor removed, they topped out at 32 miles per hour. 32 miles per hour was still a death sentence. Fletcher understood something about gear ratios that the engineers back in Birmingham didn't. Not because he was smarter, but because he'd spent 6 years solving different problems. The coal trucks he'd driven were constantly overloaded, constantly pushed beyond their specs, constantly modified by drivers who needed them to do things the manufacturer never intended. You learn to think about mechanical systems not as fixed objects, but as relationships. Change one variable, accept a different trade-off. The Bedford's gearbox had 5 forward gears. The Army used 3, first for starting, second for hills and heavy loads, third for normal driving. Fourth and fifth existed, but regulation prohibited their use except on paved roads, which didn't exist in North Africa. The reasoning was sound. Higher gears meant less torque, which meant more strain on the engine, which meant more breakdowns. But Fletcher had done the math in his head. the kind of math you learn by necessity rather than education. If you could get a loaded Bedford into fifth gear on flat ground, you could push 45, maybe 50 miles per hour. The engine would scream. It would burn oil. It would reduce the vehicle's operational lifespan by thousands of miles. But you would be alive to worry about maintenance. On December 8, 1942, Fletcher's convoy was hit by Stukas at dawn. He was driving third in a column of 18 trucks, hauling ammunition to forward positions near El Agela. The fighters came in low from the sun, their sirens screaming, and the world became dust and concussion and the smell of burning rubber. 2 trucks exploded immediately. The convoy scattered, drivers trying to find cover where no cover existed, and Fletcher felt something he'd felt before in civilian life. That cold clarity when a system is failing and you either improvise or accept the consequences. He jammed the Bedford into fourth gear. The engine howled in protest. The truck lurched, hesitated, then surged forward. He pressed the throttle to the floor and forced it into fifth. Every mechanical instinct said this was wrong. The engine was screaming at 4,000 RPM, way beyond its design tolerance. The whole chassis vibrated like it would shake apart. But the speedometer climbed past 30, past 35, past 40. He was pulling away from the bombing pattern. The Stuka pilot had calculated for a target moving at 15 miles per hour. Fletcher was moving at 42. The bombs hit empty sand 20 yards behind him. That night, while mechanics inspected the damage to the convoy, Fletcher found 3 other drivers who'd lost friends in the raid. He showed them what he'd done, not by explaining it, but by demonstrating it. They took a truck out into the desert, away from the officers, and he walked them through the gear sequence. Start in first, shift to second for acceleration, third at 15 miles per hour, fourth at 25, then force it into fifth when the engine hit 3,000 RPM. Hold it there. Ignore the noise. Ignore every instinct that said you were destroying the vehicle. He told them something he'd learned hauling coal. Every machine has a lifespan. The question isn't how to make it last forever. The question is whether you want it to last 6 months in a motor pool or 6 weeks keeping you alive. They understood. These weren't trained mechanics. They were bus drivers, taxi drivers, delivery men who'd been handed uniforms and taught to drive in formation. They understood the math of survival better than any engineering manual. Word spread the way information spreads among people who share danger, not through official channels, but through quiet conversations in motor pools, through demonstrations in the desert night, through the evidence of trucks that made it through bombing runs when others didn't. By January, 30 trucks in Fletcher's battalion were using the modification. By February, over 100. And commanders were noticing something they couldn't explain. Casualty rates were dropping, not because the Luftwaffe had reduced their attacks, not because fighter cover had improved, but because convoys were spending less time exposed, were scattering faster when attacked, were harder to target. When the reports reached battalion headquarters, the initial response was predictable. Court-martial proceedings against Fletcher for unauthorized modification of military equipment. An investigation into whether he'd sabotaged vehicles. Official inquiries into why so many drivers were violating operational procedures. Then someone did something unusual. They actually tested it. A major in the Royal Army Service Corps, a career logistics officer who'd spent 2 years managing supply lines, decided to see if Fletcher's modification worked before he decided whether to punish or promote him. They took 2 identical convoys over the same route under the same conditions. One following standard procedures, one using Fletcher's gear sequence. The difference wasn't marginal, it was categorical. The modified convoy completed the route in 6 hours. The standard convoy took 9. More importantly, when they simulated air attack, the modified convoy dispersed and reached cover in under 2 minutes. The standard convoy was still exposed after 5. The major wrote a report, not recommending adoption, but documenting the findings and noting that drivers were modifying vehicles with or without permission because they'd calculated that survival mattered more than regulations. The report should have died in bureaucracy. Instead, it reached someone who understood something about how wars are actually won. General Bernard Montgomery was many things: cautious, meticulous, often arrogant, occasionally brilliant. But he had one quality that separated him from many of his contemporaries. He paid attention to what worked, regardless of where it came from. When the report about the gear modification landed on his desk, his response was characteristically direct. If truck drivers had figured out how to reduce casualties without additional resources, then the Army would adopt what the truck drivers had figured out. On March 3, 1943, the British 8th Army issued Technical Bulletin 47/1943, authorized gear usage in Bedford QL vehicles under combat conditions. It was 3 pages long. It essentially codified everything Fletcher had demonstrated, with the added authority of official doctrine. Use of 4th and 5th gears was now permitted in combat zones when under air attack or when speed was essential for survival. Maximum sustained speed was increased to 45 miles per hour for loaded vehicles, 50 for unloaded. Maintenance intervals were reduced to compensate for increased engine wear. The bulletin included something unusual, a note that the modification had been developed by enlisted drivers through practical experimentation, and that further innovations from operational personnel should be reported rather than suppressed. It was a small acknowledgement, but it represented something larger. The recognition that expertise isn't just what you learn in school, and innovation doesn't just come from laboratories. Fletcher was promoted to warrant officer and assigned to driver training, not as punishment disguised as promotion, but because someone realized that what he knew needed to be taught. He spent the next 8 months teaching new drivers something that wasn't in any manual: how to think about vehicles as tools that could be adapted rather than systems that had to be obeyed; how to recognize when the rules that kept you safe in training would get you killed in combat; how to calculate risk not in terms of equipment damage, but in terms of human survival. The impact of the modification took months to become fully apparent. This wasn't like a new weapon that changed battles overnight. This was an incremental improvement that compounded across thousands of supply runs, hundreds of convoys, months of operations. But the numbers told the story. Between January and March 1943, before the modification was authorized, British supply convoys in North Africa lost an average of 4.2 vehicles per week to air attack. Between April and June, after authorization, losses dropped to 1.8 vehicles per week. Same enemy, same aircraft, same conditions. The difference was speed, and the willingness to trade long-term vehicle maintenance for short-term human survival. The Luftwaffe noticed. Intelligence reports from captured German documents show that by May 1943, German pilots were reporting that British convoys were becoming harder to target, moving faster, dispersing more effectively, spending less time exposed. The Germans responded by increasing the intensity of attacks, which stretched their already limited resources thinner. More sorties meant more fuel consumed, more aircraft maintenance, more pilot fatigue. The strategic calculus shifted. Attacking British supply lines was becoming less efficient, which meant German air assets were needed elsewhere, which meant British convoys faced fewer attacks, which meant more supplies reached the front. One modification to gear usage, implemented by a truck driver with no formal engineering training, had created a cascading effect across the entire logistics system of the North African campaign. This is how wars are actually won, not through single decisive moments, but through thousands of small improvements that accumulate into strategic advantage. Fletcher's modification was adopted beyond North Africa. British convoys in Italy used it. In France, after D-Day, it became standard procedure. The Americans studied it and implemented similar changes in their own supply vehicles. By late 1944, the basic principle that truck speed mattered more than truck longevity in combat zones had been integrated into logistics doctrine across the Allied forces. But the deeper story isn't about gears or convoys. It's about the psychology of institutional learning and resistance to innovation from unexpected sources. When Fletcher first demonstrated his modification, the immediate response from many officers was dismissal, not because the modification didn't work, but because it violated their understanding of how innovation was supposed to happen. Innovation was supposed to come from engineers, from laboratories, from people with credentials and authority. It wasn't supposed to come from a sergeant who'd driven coal trucks in Manchester. This is cognitive bias in its purest form. The assumption that expertise resides in institutions rather than experience, that valid knowledge comes from formal education rather than practical problem-solving. Fletcher had no engineering degree, but he had 6 years of solving mechanical problems under constraint, which gave him a kind of knowledge that formal education often misses. He understood vehicles as systems that could fail, that could be pushed, that could be modified when the stakes demanded it. The officers who initially opposed the modification weren't stupid or malicious. They were operating from a perfectly logical framework. Vehicles have specifications for a reason. Exceeding those specifications causes damage. Damaged vehicles become maintenance burdens. Therefore, modifications that exceed specifications are counterproductive. The logic was flawless. The problem was the framework. That framework assumed that vehicle longevity was the primary concern. It didn't account for the fact that a truck that lasts 6 months in a motor pool is worthless if the driver is dead after 2 weeks because the truck was too slow to escape a bombing run. Fletcher understood something the framework didn't. Survival changes the equation. When you're being bombed, the relevant question isn't how long the truck will last. The question is whether you'll be alive tomorrow to worry about maintenance. This is the psychological weight of being right when the system says you're wrong. Fletcher knew the modification worked. He demonstrated it. Other drivers had survived because of it. But for weeks, he faced the possibility of court-martial, of being punished for innovation that saved lives because it violated procedure. Think about that position. You possess knowledge that could save your comrades, but sharing that knowledge means risking consequences because the institution hasn't validated it yet. Do you stay quiet and protect yourself, or do you share it and accept that you might be punished for being right before the system recognizes you're right? Fletcher chose to share, not because he was particularly brave or principled, but because he'd watched friends die and couldn't live with staying silent. But not everyone made that choice. How many other innovations were suppressed because someone calculated that the personal risk of defying procedure outweighed the collective benefit of sharing knowledge? How many soldiers died because the person who could have saved them decided that keeping their head down was safer than speaking up? This is the cost of institutional rigidity, not just the innovations that are rejected, but the innovations that never get proposed because people learn that the system punishes deviation regardless of outcome. The fact that the British Army eventually adopted Fletcher's modification is significant. It suggests that at least some parts of the military hierarchy were capable of learning, of recognizing that expertise could come from unexpected sources, that survival sometimes required breaking rules written by people who'd never faced the situations those rules were meant to govern. But the adoption took months. And in those months, drivers died who might have lived if the modification had been authorized immediately after it was demonstrated to work. This is the gap between validation and implementation, the time between when something is proven effective and when institutions accept it as doctrine. In peacetime, that gap might be acceptable. In war, measured in lives, it becomes a moral weight. Montgomery's decision to codify the modification was unusual, not because it was radical, but because it acknowledged something most institutions resist: that the people closest to a problem often understand it better than the people managing them from a distance. That lived experience is a form of expertise. That innovation isn't just about laboratories and formal research, but about practical experimentation under constraint. The technical bulletin that authorized the gear modification included that note about innovations from operational personnel. It was buried in bureaucratic language, easy to miss. But it represented a shift in thinking. The recognition that the Army didn't have a monopoly on problem solving, that solutions could emerge from anywhere in the hierarchy, that the job of leadership was to identify what worked and scale it, rather than control who was allowed to innovate. This is cultural change disguised as policy. And like most cultural change, it happened slowly, unevenly, with resistance and backsliding. But it happened. And it happened because one truck driver refused to accept that procedure mattered more than survival. After the war, Fletcher returned to Manchester. He drove trucks again, but not coal trucks. He ended up working for a logistics company that hired him specifically because of his military experience. He spent 20 years optimizing delivery routes, training new drivers, solving problems that formal education hadn't prepared managers to recognize. He never talked much about the gear modification. When people asked about his war service, he'd say he drove trucks, which was true, but insufficient. What he'd really done was demonstrate that innovation isn't about credentials or authority. It's about recognizing when the rules don't match reality and having the courage to do something about it. The story of Fletcher's modification is often told as a feel-good narrative about the little guy beating the system. But that framing misses the deeper truth. This isn't about individuals versus institutions. It's about how institutions learn or fail to learn from the people who operate within them. The British Army didn't fail by having regulations about gear usage. Those regulations made sense given what was known about vehicle maintenance and the importance of preserving equipment. The system failed by being slow to recognize when conditions changed those calculations, when new information from operational experience should have overridden established procedure. Fletcher succeeded not by defying the system, but by forcing it to confront evidence it had been ignoring. Every driver who survived a bombing run because they were moving at 45 miles per hour instead of 15 was a data point the system couldn't dismiss. The modification worked. That wasn't opinion or theory, it was measurable outcome. And eventually, enough measurable outcomes accumulated that the institution had to adapt or accept responsibility for preventable deaths. This is how change happens in hierarchical systems. Not through top-down mandates, but through bottom-up pressure backed by evidence that becomes impossible to ignore. The question is, how much evidence is required? How many deaths are acceptable before adaptation? How long the gap between proof and implementation? In Fletcher's case, the gap was months. That was faster than most institutional change, but it was still months. And men died in that gap. This is the moral weight that institutions rarely acknowledge, the cost of their own inertia, the price paid by the people at the operational level while the people at the strategic level debate and validate and process and finally, eventually, reluctantly, accept what those operational people have been demonstrating all along. The philosophical question embedded in this story is deeper than military history. It's about epistemology, about how we know what we know, about who we trust to tell us what's true, about the relationship between formal knowledge and practical wisdom. Western culture, particularly in the 20th century, developed a strong bias toward credentialism, the belief that valid knowledge comes from formal institutions, from universities, from certified experts. This bias isn't entirely wrong. Formal education provides frameworks, rigor, accumulated knowledge that experience alone might miss. But the bias becomes dangerous when it dismisses or devalues knowledge that comes from other sources, when it assumes that someone without credentials can't have expertise, when it creates barriers between the people who study systems and the people who operate them. Fletcher had expertise, just not the kind that institutions were trained to recognize. He understood mechanical systems through thousands of hours of practical interaction. He understood risk calculation through experience making life or death decisions about vehicle operation. He understood innovation through years of solving problems with limited resources. But none of that expertise came with credentials. So when he proposed a modification, the initial institutional response was skepticism. Not because his idea was bad, but because he wasn't the kind of person institutions expected good ideas from. This is cognitive bias compounded by hierarchical thinking. And it's costly, not just in this specific case, but across all domains where the people closest to problems are systematically prevented from solving them because their knowledge doesn't come in the form institutions validate. Think about how many innovations never happen because the person who could implement them doesn't have the credentials to be heard. Think about how many problems persist because the people who understand them best have learned that speaking up is professionally dangerous. Think about the gap between what organizations claim to value, innovation, adaptation, problem-solving, and what they actually reward, conformity, credentialism, deference to hierarchy. Fletcher's story is the exception that proves the rule. He succeeded. The Army adopted his modification. Lives were saved. But he succeeded despite the system, not because of it. He succeeded. Because he was willing to risk consequences. Because other drivers were willing to adopt unauthorized modifications. Because one major was curious enough to test rather than punish. Because Montgomery happened to care more about effectiveness than protocol. Remove any one of those factors, and the outcome changes. Fletcher gets court-martialed, and the modification dies with his military career. Or it stays confined to a few drivers who keep it secret to avoid punishment. Or the report never reaches anyone with authority to change policy. Or it reaches someone who decides that maintaining institutional authority matters more than reducing casualties. The fact that it worked out doesn't mean the system worked. It means the system failed more slowly than the informal network of drivers who were adapting faster than doctrine could keep up. The real success wasn't the gear modification. The real success was that enough people within the institution recognized practical wisdom when they saw it and chose to validate it rather than suppress it. That's rare, and the rarity is the problem. After the war, military institutions studied logistics extensively. They wrote doctrine about supply chain management, about vehicle maintenance, about optimal gear usage. Much of that doctrine incorporated lessons learned from operations in North Africa and Europe. Some of it explicitly referenced innovations from operational personnel. But the deeper lesson that expertise resides throughout an organization and innovation can come from anywhere, that lesson was harder to institutionalize because it requires humility. It requires leaders to admit that people below them in the hierarchy might understand things they don't. It requires systems to create channels for bottom-up information flow that can override top-down control. It requires accepting that credentials and experience are different forms of expertise and both have value. Some institutions learned that lesson, some didn't. The ones that did tended to be more adaptive, more innovative, more effective. The ones that didn't tended to be rigid, slow to change, increasingly disconnected from operational reality. You can see the pattern across military history. The organizations that win aren't necessarily the ones with the best technology or the most resources. They're the ones that learn fastest, that adapt quickest, that can recognize when reality has invalidated their assumptions and change accordingly. The British Army in North Africa was facing institutional obsolescence. Their logistics doctrine was based on assumptions about vehicle durability that made sense in peacetime but failed in combat. They were losing the race between German air power and British supply capacity. Fletcher's modification was one small adaptation, but it was part of a larger pattern of learning, of taking operational experience seriously, of being willing to change doctrine when evidence demanded it. That capacity for institutional learning, more than any single weapon or strategy, was what allowed the Allies to win. They made mistakes. They were slow to adapt in many areas. But overall, they learned faster than the Axis powers. They were better at taking information from the bottom of the hierarchy and using it to change policy at the top. And that advantage compounded over time until it became decisive. This is the unsexy truth about military victory. It's not about heroic charges or brilliant generals or wonder weapons. It's about logistics, maintenance, supply chains, and gear ratios. It's about organizations that can learn from truck drivers and implement their innovations before too many people die from institutional inertia. Fletcher understood this, not in those terms, not as grand strategy, but he understood that wars are won by the people who show up every day and solve the immediate problems in front of them. The people who drive the trucks, who maintain the equipment, who figure out how to survive long enough to complete the mission. The modification he developed saved lives, but the deeper contribution was demonstrating that practical wisdom matters, that experience is expertise, that the person in the cab of a truck under fire might understand survival better than the engineer who designed the truck in safety. This is the knowledge gap between theory and practice, between how systems are supposed to work and how they actually work, between doctrine and reality. Every institution faces this gap. The question is whether they have mechanisms to recognize when the gap exists and close it, or whether they defend their theories against evidence until catastrophic failure forces adaptation. The British Army, in this case, had just enough institutional flexibility to recognize and adopt Fletcher's modification before the human cost became unacceptable. That's not a story about the system working perfectly. It's a story about the system working barely well enough, barely fast enough, to save some of the lives that slower institutions would have sacrificed to procedural inertia. And that's the standard we should hold institutions to. Not perfection, but speed of learning. Not absence of mistakes, but willingness to recognize and correct them. Not top-down control, but the humility to listen when the people closest to a problem tell you what actually works. Fletcher's gear modification is a small footnote in World War II history. It doesn't get mentioned in most books. It didn't win any major battles. But it represents something essential about how wars are won and how organizations survive. Innovation under pressure, practical problem solving, the courage to challenge procedure when lives are at stake, and the institutional wisdom to recognize expertise regardless of where it comes from. In the end, the story is simple. A truck driver figured out how to make convoys faster. He shared what he knew despite the risk. The Army eventually listened. People lived who otherwise would have died. But embedded in that simplicity is everything that matters about human organizations trying to solve hard problems under constraint. The gap between knowledge and authority, the cost of institutional inertia, the value of practical wisdom, the moral weight of choosing between procedure and survival, and the question every hierarchical system has to answer. Do you want to be right according to your own rules, or do you want to be effective according to reality? Fletcher chose effectiveness, and in choosing, he saved lives and demonstrated something that formal military doctrine had overlooked. That sometimes the most important innovations come not from laboratories or command centers, but from the people in the field who understand that survival requires adaptation and who have the courage to adapt even when the system tells them not to. That's the lesson. Not about gear ratios or convoy tactics, but about listening to the people who know even when, especially when, they're not the people you expected knowledge to come from. And in war, as in everything else, that lesson is the difference between organizations that learn and organizations that die still defending the doctrine that killed them.